More quadratics, real-life adventure problems. 1.5 is quadratic modeling, and what we're going to end up doing in here is I'm going to go through a couple of examples. The solving on these things shouldn't be the hard part because you're going to be able getting a quadratic equation that you're going to be able to plug in and use, or come up with the quadratic equation with information, and then from there use the quadratic equation or quadratic formula, or the factoring or any of the other techniques that you use. So I'm going to focus mostly on setting these up, and I may end up just tossing the question out, the answers out to you later. Make sure that if you have not printed out the note sheet for this, I do have one right next to the video file on the main page. So go ahead and if you can print that out, that'll probably be fairly helpful. Again, some of these problems are not going to be real life because some of them are not necessarily you're going to be figuring them out this way. But again, it's just a matter of getting some simple stuff up. Plus, you kind of get some use to setting up the equations from scratch. And then also, ECT, SAT stuff doesn't always use the most real-life problems that you have. Okay, disclaimers aside. Shopping center has a rectangular area of 40,000 square yards and enclosed on 3 sides for parking lot. The length of 200 yards is more than twice the width. Find the length of the lot. Why would you need this? Maybe you need to put a fence up. Maybe you need to give the dimensions to somebody who's going to be paving it. I don't know. Whole bunch of reasons, or maybe your boss told you to figure it out and that's it. And let's face it, when your boss tells you to do something, you tend to do it. So there is a rectangular lot. It is 40,000 square yards. Okay. And is close to that. And in this case, it's not necessarily, I guess, well, we'll talk about that in a second. The length is 200 more yards than the width, so then twice the width. So this is your width, this is twice your width, and it's 200 more than twice the width, so you use up this 200. The reason why this may be important is the enclosed on 3 sides part. In this case, you don't have to worry about it, but in some cases, they may be saying that you've got a fence that's on 3 sides, and so that's how much you need to enclose on both sides or something like that. And so you don't have to, that will affect some of what you do. So anyway, in terms of, again, remember area is length times width on these things, right? So area equals length times width, and it's also equal to, in our case, 40,000 square yards. I'll leave my handwriting getting better, but you guys can probably disagree if you need to. So anyway, so your length is going to be 2w plus 200. Your width is w. And so now you have a quadratic equation. Now to make it work, you're going to have to actually multiply this out. So I get 2w squared plus 200w minus 40,000 equals 0. And you're going to have to solve that out. Different options to that extent. If you want to, actually this is probably going to be factorable to some extent, but you could plug this in a straight quadratic equation. Since everything's even, you could factor out a w, make the numbers a little bit nicer for yourself. Oops. Dun, dun, dun. Sorry, I erased too much. So then you can get 100w minus 20 equals 0. So you need to find two numbers that multiply out to be 20,000 and add up to be 100. And in this case, you get 2 times, unless my memory is failing me, plus 500, and then w minus 400. 4 times 5 is 20. Add on 2 zeros. Wait, that's not enough. Dun, dun, dun. I guess that would be a mistake. Alright, we'll do the old-fashioned. Alright, bring camp aside. So you can get 2. This does factor out. You're going to get w. And then you're going to get plus 200. And then minus 200. Yeah. And then, gosh. nice, probably a couple in a week or so. And then you get W minus 100. So 100, negative 100 plus 200 is 100. Multiply this together, you get 20,000. So then your answers are going to be negative 200 and 100. Yay. But wait, you're not done. First of all, that looks like a 3. Second of all, you have to check context. Does it make sense that you could have a width of 100 yards? Yes. Does it make sense that I have a width of negative 200 yards? No. So we're going to cross that one off. That does not work. And so our answer is going to be, and width is, you know what, let's try this. It's 100 yards. Now notice we're not done yet because he said length and width. Okay, and the length, if you remember from the original problem, hello. If you remember from the original problem, is 200 yards more than twice the width. So you get the length is 100 yards, and the length is 400 yards. This again, double the 100, so you get 200 plus another 200. And there you go. And then double check it, and obviously 100 times 400 is the answer of 40,000 square yards. Okay. Now sometimes they're going to actually give you the equations, so you don't have to really worry about that much. Like in this case, astronaut on the moon throwing a baseball upwards. Why? Because he can. Actually, I think it was Alan Shepard smuggled aboard the second moon landing a pitching wedge and some golf balls, and so he was hitting golf balls out on the moon's surface, and the engineers back in NASA had to fit because obviously those things all weighed something, and so when you're calculating out how much fuel you need to bring along and burn times and all that other stuff, they were complaining that that could actually that could have thrown off how much things were you could have thrown it, I think they said killed. So anyway, so you have this astronaut throws a baseball upward. The astronaut is 6 feet 6 inches tall. Initial velocity of the ball is 30 feet per second. All of this you can come up with a whole bunch of stuff. The height of the ball in feet is given by the equation of this. A couple of things, just so you know, this is the coefficient to half the coefficient flow of gravity, or the gravity on the moon. That's it. 30 is how fast the ball's initially going. 6.5 is the height of the guy or woman. And then that's not going to be something that you can have necessarily. I'll let your physics teachers discuss that with you. Okay, t is the number of seconds after the ball was thrown, and then s remembers height. So how many seconds is the ball 12? After how many seconds is the ball 12 feet above the moon's surface, around the nearest hundredth? So for that, what you're going to end up doing is, again, you're just going to plug in what you have. So this is going to be 12 is equal to a negative 2.7 t squared plus 30t plus 6.5. So then the equation you're going to solve is that you have to remember set everything equal to 0. So you're going to get the negative 2.7 t squared plus 30t. Wow, that's awful. Minus. Okay, so then from there, you're going to go through and solve the quadratic equation, solve it by completing the square, which I would not recommend because of this 2.7. Whatever. Go from there. Your answers, by the way, it turns out that your answers are going to be, let's see, 10.92 seconds and 0.19 seconds. Now for this one, how many seconds is the ball 100 feet off the moon's surface? So you've got 100 feet Again, that's your height, negative 2.7 t squared plus 30t plus 6. So again, you can move the 100 over, you can solve it. Now the thing is, with this one, you're going to come up with imaginary answers. Okay, so when you solve it, you're going to get a determinant that's negative. And so if that's the case, okay, you're going to get no answers because, again, imaginary numbers can't exist. And last but not least, this one here, how many seconds does it take to rest on the surface of the moon? Well, what's the surface of the moon? The surface of the moon is 0. So you get negative 2.7 t squared plus 30t plus 6.5. So here you're just going to solve this. And you're going to come up, when you go down here, you're going to come up with two answers. T is going to equal a negative 0.21 and, or I should say, or T is going to equal 11.32. Okay? And now what happens here is that this answer over here can't exist. The reason why this one can't exist, is because a negative answer is actually, if you think about it, the astronaut is throwing it from a height of 6.5 feet. And because of that, if you backtrack, it starts at 0. So it's not starting from a set position down at 0. So anyway, that's going to be that. Those are some examples. You're going to do some more in class. Those are the problems that you're going to be working on in class. So enjoy, and we'll see